All right, we're going to talk about 1.7, which talks about the combination of functions and composite functions. So these are our 5 objectives. So being able to find the domain of a function, combine functions using algebra of functions, specifying the domains, form composite functions, determine the domains for the composite functions, and then write functions as compositions. So let's fill in the blank here. It says if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So we want to find what that's saying is what are all the possible values for x. So what do we exclude? What causes a number to be left out of the domain? Numbers that cause division by 0. So whatever would make the denominator 0 has to be excluded from the function's domain. Real numbers that result in an even root, such as a square root of a negative number. So numbers that would make a number negative underneath an even root radical. Those are the 2 exclusions. So we'll look at this with this problem here. So this asks us to find the domain of this given function g. And when you see this and you're asked to find the domain, I want you to ask yourself 2 things. I want you to first assume the answer is all real numbers, except if the 2 items that you're going to ask yourself exist in the problem. So you want to think, my answer is going to be all real numbers. But there are some exceptions. So what are the things I should exclude? Ask yourself, is there any number that would cause the denominator to be 0? The only way that you can have a denominator equal to 0 and look for that number is if x is in the denominator. So the first question you're going to ask yourself, is x in the denominator? And if it is, then what you do is you're going to set the denominator equal to 0, and you're going to solve for x. That will give you the exclusion. So in our problem here, is x in the denominator? Yes. I see an x in the denominator. So I set the denominator equal to 0. And then I solve. So this is different than some of the other problems we've seen so far. This is a quadratic. Now, since this quadratic is missing the middle term, it's easier to solve. So we can isolate the x in this quadratic. So I've added 49 to both sides. I got this. And now I'm going to take the square root of both sides. And I get x is equal to plus or minus 7. The square root of 49 is 7, but also you can take the square root of 49 and get negative 7. So far, there are 2 numbers that make the denominator 0. And those are negative 7 and positive 7. So I need to tell my reader that my answer here so far is all real numbers besides positive or negative 7. So I drew this number line And I'm going to draw the values that so far work. So below 7, below -7, I mean, between -7 and +7, and then above 7. So far we have this. Now, I said there was 2 questions you have to ask yourself. The second question, you want to check if the second part of the prior page, any number that would make the radicand, a radicand is the number or expression underneath the square root symbol or the radical sign. Any number that would make the radicand negative. And it has to have an even root. So, like the square root, the 4th root, the 6th root, the 8th root, all those even roots. So the question you're going to ask yourself is, if under the square root or even index root. So if it's a cubic root, a 5th root, 7th root, we don't have to worry about this. So you're going to ask yourself, if you have a square root or any even index root, is there an x in the radicand? If there is, then set the radicand greater than or equal to 0 and solve for x. This will give you your domain. So when we solve for x in step 1, that gives us the exception. This one gives us the domain. So does the second question apply here? Well, in this function, there is no square root symbol. There's no radical sign. So then this doesn't apply. So the only one I have to test is this top one, which we did already. And now I just need to give my answer. So, and I want to point out that there are 3 parts to this answer, because I want to give my answer. It will usually say, write your answer in interval notation. So there's a part below -7. There's a part above +7. And then we don't want to forget there's a part between -7 and +7. So I need to express all 3 of those parts. And I'm going to express them each in interval notation, keeping in mind that as we go to the left, we go to -infinity, and as we go to the right, we go to +infinity. So the left side here in yellow, to write that in interval notation, I would say smaller endpoint, comma, larger endpoint. And I'm excluding -7, so I'm going to use a parenthesis. Infinity always has a parenthesis touching it. For the blue part, that's the part between -7 and 7. So which is the smaller endpoint? -7. +7 is the larger endpoint. I'm excluding both -7 and 7, so parentheses on both sides there. And then lastly, I'm going from 7 to infinity. Positive infinity is always the concept of the largest number. So I'm putting that on the right, and I have the parenthesis on both of them because I'm excluding 7, and infinity always has a parenthesis touching it. And then I'll put this U in between, that's the union symbol, to tell the reader that it's the union of all 3 of these pieces. So this will be my answer here. So in a word description, it would be all real numbers except -7 and +7. But this is the answer written in interval notation. So let's look at the next one. Here we have, it says find the domain here of function h. Now with function h, we want to ask ourselves the two things. Is there an x in the denominator? And the answer there is no. So then I don't have to do that step. Then I'm going to ask myself, is there an x under an even root radical? And the answer is yes. Now, if you answered no to both of these, then your answer, you would say the domain is all real numbers, and in interval notation, that would be -infinity, +infinity. But in this case, we answered no to the first question, but yes to the second. So if that's the case, then I'm going to take remember I said the radicand, it's just this part, not including the square root symbol. And I'm going to take the radicand and I'm going to set it greater than or equal to 0. And then I'm going to solve for x. So solving for x here means I'm going to, I know this is an inequality symbol, but the inequality symbols work very similar to a regular equal sign. You can do the same steps. The only thing you have to be careful with is if you divide or multiply both sides by a negative number, it's going to flip this inequality sign. So this is my answer. Now remember, when you do the first one, whatever you get there is the exclusion. When you do the second one, whatever you get there is the domain. So this is the domain. So what's that? What I like to do before I put it in the interval notation, I will draw it on a number line. So where is -4? Well, -4 is here. And -4 to +infinity goes to the right. Greater than or equal to -4 would be this way. Now, and some books write it with a bracket, some books write it with a closed dot. You can do it either way. Writing it with the bracket makes it easier when you change it to interval notation, because then you're going to say, that's the symbol I'm using here. So this is -infinity, or I'm sorry, -4 to +infinity. That is my answer. So my domain is this. Meaning if I choose any number outside of this red highlighted area, it would not work here. So let's say I chose -10. That's outside. I would end up with the square root of -6, and that doesn't work. If you put that in your calculator, it wouldn't work. But if I choose anything to the right here, -4 or higher, then I'm going to get a value that will work in here. So let's say I chose 0. 0 plus 4 is 4. The square root of 4 is 2, or -2. So it works for that. It does not work for numbers this way.